MIT researchers have invented a machine learning tool that predicts how fast computer chips will execute code from various applications. To get code to run as fast as possible, developers and compilers, that is, programs that translate programming language into machine-readable code, typically use performance models that run the code through a simulation of given chip architectures. Compilers use that information to automatically optimize code, and developers use it to tackle performance bottlenecks on the microprocessors that will run it. But performance models for machine code are handwritten by a relatively small group of experts and are not properly validated. As a consequence, the simulated performance measurements often deviate from real-life results. In a series of conference papers, the researchers describe a novel machine learning pipeline that automates this process, making it easier, faster, and more accurate. In a paper presented at the International Conference on Machine Learning in June, the researchers presented iThermal, a neural network model that trains on labeled data in the form of basic blocks, that is, fundamental snippets of computing instructions, to automatically predict how long it takes a given chip to execute previously unseen basic blocks. Results suggest iThermal performs far more accurately than traditional hand-tuned models. Then, at the November IEEE International Symposium on Workload Characterization, the researchers presented a benchmark suite of basic blocks from a variety of domains, including machine learning, compilers, cryptography, and graphics that can be used to validate performance models. They pooled more than 300,000 of profiled blocks into an open source dataset called Beehive. During their evaluations, iThermal predicted how fast Intel chips would run code even better than a performance model built by Intel itself. Ultimately, developers and compilers can use the tool to generate code that runs faster and more efficiently on an ever-growing number of diverse and black box chip designs. Most recently, in a paper presented at the NeuroPS conference in December, the team proposed a new technique to automatically generate compiler optimizations. Specifically, they automatically generate an algorithm called WML that converts certain code into vectors, which can be used for parallel computing. WML outperforms handcrafted vectorization algorithms used in LLVM compiler, a popular compiler used in the industry.